Okay, for this problem, we have Spider-Man, my crappy drawing of Spider-Man, hanging out on a rope. It says he has a mass of 70 kilograms, okay? And the rope is pulling up 1,000 newtons. And they're asking you, what is the acceleration of Spider-Man? All right, first thing we're going to do, we're going to draw a free body diagram. So we're going to look for the forces that are acting on Spider-Man. One of them is definitely force of gravity. Okay. Force of gravity is pulling downward. Another force that's going to be acting is tension. Because this is a rope, it's going to be tension. Which of those two is winning? Well, we know that it says Spider-Man is going upward. He's accelerating upward. So we know that the force of tension has got to be greater. So we're going to draw it longer than our force of gravity. What we're going to do now is we're going to write those two equations that kind of help us organize stuff. So one of them is F net is equal to mass times acceleration. We write that same thing every time. Really helps. The other equation we're going to make by using our free body diagram. So you're going to look at it, and it's always up minus down in situations like this. So force of tension minus the force of gravity. All right. Let's look at what we know. I like to gently underline what I know when I start out a problem to figure out what's going on. Well, they gave me the mass. They gave me the rope pulling up, which is our tension, so I know that. And they're asking for the acceleration. So what I'm going to need to find is, well, if I wanted the acceleration, the thing that's holding us back is this net force. So I'm going to have to find that. Here's net force, but I don't know everything I need to know right now. I still need to find my force of gravity in order to get that. That's not too bad, though. Please remember that if you ever know the mass, you know the force of gravity and vice versa as long as you're on Earth. The equation that relates those is Fg is equal to mg. Okay, so Fg is equal to 70, and acceleration due to gravity is 9.8. So our force of gravity is 686 newtons. Now that we have that, we can apply that back into our equation. So F net is equal to force of tension they gave us. That's how much the rope was pulling up. So that's 1,000 minus our force of gravity was 686. So the net force, the total force acting on Spider-Man is 314. So 314 newtons. All right, that is useful because we can put that back into this equation and we can solve for the acceleration. So F net is equal to mass times acceleration. So 314 is equal to 70 times my acceleration. You can divide by 70. And Spider-Man's acceleration is 4.5 meters per second squared. And as the kids say, Yahtzee.